factors that affect rate?
The concentration, temperature,
Temperature.
Right. So the first thing they ask, right, says say two factors that affect rate. That affect rate. So we know concentration, temperature, and you can list them because I know you know them. All right.
Pressure.
Particle size and pressure. All right. So the next question, we get a table. I am not going to do all of the table. All right, so part B, we have this reaction, hydrogen with 2NO H2O plus N2, which is a gas. So from the graph, what graph? Not graph, from the data. All right, so to calculate the order of the reaction, you can look at the table and just figure it out. But in the interest of time, I'm going to show you how to calculate it because they can also miss. All right, so you can actually calculate the order of the reaction. So I'm going to start with hydrogen, and I'm going to use this formula. You have class in here now? All right. All right, so what you're going to do now, right? You're going to look for two experiments in which you change the concentration of hydrogen while keeping NO constant. All right. So if you look at experiments 1 and 2, you change the concentration of H2 while keeping the concentration constant. All right. So for experiments 1 and 2, the rate 2 is the bigger one. So it would be 6 times 10 to the minus 3 divided by 3 times 10 to the minus 3. You are going to get 2. And then for hydrogen, it would be 2 times, up here, 2 times 10 to the minus 3
So
yeah.
you got decipher the units them?
Please repeat.
You got deduce the units them? The units for rate, I mean. To me.
What about it? If I'm going to show you how to work it out?
Yeah.
Yeah, man. All right. So, right. So this will give you 2 to the M. All right. When you get to this part, it's a log. All right. So all you will say, right? All right. So 2 is equal to 2 to the M. M is the order of the reaction. This is a bit much. I'm not sure how they did it because I didn't do logs. But what you will say is log 2 is equal to M log 2. So all you're going to do, right? Divide rate 2 by rate 1. You'll get the answer. The second concentration over the first one. All right. When you get the answer, 2 is raised to the power of M. They use log to solve it. Right? So all you do is put log in front of this 2. So I'm going to get log 2 is equal to M log 2. So to get M, it's equal to log 2 over log 2. You're going to get 1.
So, sir, do you necessarily have to find a log? Because, like, normally what I do is just, like, divide the 2 and then I would get a 1.
Yeah, if you divide 2 by 2, you're still going to get the 1. But as in 2 raised to the power of M to make M the subject, they use log. But you don't have to, because you will still, if you look at it, if you divide 2 by 2, you will still end up with the 1. But that's the maths behind of it. All right.
Well, I think one other way we could look on is that the 2 over on that side when I have no power is actually 2 to the 1, just equal to 2 to the M. Since M equal, 2 to the 1 must be equal to 2 to the M. M must be 1.
All right. So if you know if you do that, it can be, but it will work out as the other female had said. Once it will work out to be the one, regardless. All right. Because when you reach here, if I want to say M is equal to 2 over 2, we will still end up with it being a 1. All right. So depending on the table you get, the numbers might seem off. I don't know how to compare them. All right. So, all right, what is the order of this reaction? First order, second order, what is it?
First.
Right. Once it's 1, it's first order. All right. So with respect to hydrogen, it is first order reaction. Now, if you know how to interpret the table, you double the concentration of H2 and the rate also double, so it is first order. All right. So if you are able to just look at it, but some students have difficulty. So I'm showing you how to just calculate it, all right? And they can ask you to calculate it. They did not in this case, but I'm just showing you so you can know how to do it. All right, if we're doing N, yeah, quickly.
One question, if it was zero order, you wouldn't get no change in the rate.
That is correct.
All right.
Yeah, man. All right, let us, so for NO, tell me 2 experiments, somebody quickly, tell me 2 experiments I can use for NO.
3 or 4.
3 and 4? No, we can't use 3 and 4.
Sir, we'll have to use 1 and 4, sir. Wait, no.
Yeah, but no,
Anyone that's really constant for the hydrogen.
Yes, sir.
Right, so repeat the answer. Did you say 2 and 3?
I've not seen anyone that's any concentration that's remaining constant for the hydrogen.
Oh, all right. Oh, yes, that's true. Let me add the next one. Sorry. So that's correct. All right, so question number 5. All right, 6 times 10 to the minus 3 and 2 times 10 to the minus 3, right? And then the rate is 2 times 10 to the right. So we can use experiment 4 and 5. So remember, when you are selecting your experiment for a particular reactant, so now we want to know the order of reaction with respect to NO. So you have to look at 2 experiments that you change the concentration of NO, right? So you could have used 3, yes?
Sorry, but I don't think I really understand how you get the 2 times 10 to the 3 for the rate.
Where?
Experiment 5.
This?
Experiment 5, sorry.
Just added, sir.
Over here?
Experiment 5, we just add.
Yes, sir.
No, man. So the actual past paper, it gave us 6 experiments, but I just put 4 on the board.
Oh.
Yeah, but right. So I realized that for NO, we couldn't use any of the 4. So I added a 5th one. Yes, so it's actually 6.
Okay, sir, thank you.
So it was 6. So, all right, so just 6 times 10 to the minus 3. And this was 3 times 10 to the minus 3. And this was 4.5 times 10 to the minus 3. All right, so as I was saying, we want to know the order of reaction with respect to NO. So you look for 2 experiments in which you change the concentration of NO. So we could use experiment 3 and 4. However, for those 2 experiments, the concentration of H2 has to be constant. So for that reason, we cannot use experiments 3 and 4 because these 2 are not constant. If you look at experiment 4 and 5, you change the concentration of NO while keeping the concentration of hydrogen constant. You could also use experiments 4 and 6. All right, so for NO, four and 5, or we could use, where is it? 4 and 6, or 5 and 6. Because in 5 and 6, you change it, this kept constant. For 4 and 5, you change this while keeping H2 constant. Right, it is going to be second order. All right, so just like before, it's rate 2 over rate 1. All right. So I'm going to erase this. All right, so which experiment you want to use? All right, let's use 4 and 5. All right. So we're going to do this using experiment 4 and 5. So 2/1. So rate is 2 times 10 to the minus 3 divided by 1 times 10 to the minus 3. That is equal to 2 times 10 to the minus 3 divided by 0.5 times 10 to the minus 3. So this is going to be equal to 2. This will give you 4. All right. So the order is equal to 4/2, which is equal to 2. If you want to do it the log way, you would get 2 is equal to 4 to the m. All right. So m would be equal to log 4 over log 2, and you would still end up with 2. All right. So you see, it's pretty straightforward how to get the order of the reaction.